welcome back to my lecture. So, we will go to the second lecture. In the second lecture, we shall now get into slowly into different parts of the things. So, as I said earlier that we have two things here to deal with, one is power, one is information. So, this is what is power, we consider power. So, we will consider power first. So, in the first part of lecture we will consider power, we will focus on power. So, power means, so there is three things, that is power generation, as I said generation, then what, transmission, then distribution. This is 1, 2, 3, distribution, four is utilization. So, we will focus on these four. Then we will, I am just giving you the outline of the lecture, you must be knowing. Then we will see, mostly we will focus on two things, transformers, lines, that is conductors or cables for power transmission, and utilization we will consider motors. These are the three things we will cover, transformers, cables and motors. So, then we will decide about the control, that is how to control, so converters. So, these are the things. Before that, let us again get into little bit of the inside of the drag line. So, you can see this is the drag line, you can see how the motor looks like, it is a huge motor, as you can see, it like a powerhouse, there are lot of cables, cooling system is there, these are cooling system. So, this is intersection, dissection of a drag line, and there are lot of towers, power converters, as you can see here, with control and switch gears, everything is here. There is a transformer here, you can see this is a transformer. Laser pointer will use. So, this is a transformer, the motor, there are lot of converters. So, this is a briefly some kind of outline which I have generated this picture. This is not a copyright protected. So, this is what. So, let us get into more. So, what is the primary power source here? The primary power source here is the high voltage grid, utility grid. That means, after the power is transmitted, we are having a utility grid. From the grid, we are transmitting grid. It is called grid. Grid means all these power generating stations of the country, they are connected to a common grid. It is a common circuit, three-phase circuit everywhere. Odisha, West Bengal, UP, everything is connected to a common grid. This is called national grid. So, the power generating station, there are different power generations. Power generation can be by steam generation, it can be coal, one is power generation is by coal fired, it can be nuclear also. So, that means it can be also solar, it can be hydro. Nowadays people are talking about hydrogen fuel, green hydrogen. So, there are lots of ways. One is solar, which is non-conventional, wind, there can be coal. So, these are some of the things. So, coal is the primary source, then we are also replacing by nuclear, then there is this hydro, and there is this solar, then there is this wind, then nowadays people are talking about hydrogen fuel. Hydrogen fuel means hydrogen. How to generate hydrogen? By green fuel. Green means hydrogen itself will be generated from sea water by wind energy. So, hydrogen can be a fuel, beautiful fuel, and these are the principle of fuel cells nowadays. People are talking about fuel cells. Okay. So, these are different conventional, these are conventional, the hydro, coal, etc., even nuclear, and these are unconventional, solar, wind, and there is tidal energy nowadays, tidal, that means from the sea, geothermal energy. So, there are a lot of energy sources. So, these energy sources are called generations. This is called generation, as I said. This is generating stations. These generating stations are distributed all over the country. So, you can say power generating stations, PGS, power generating stations. These are all over the country. So, there are power generating 1, 2, 3, 4 different power PGS2, PGS3 like that, it is all over distributed all over the country. So, they are all connected to a common grid. So, it is feeding power here, it is feeding power here, it is feeding power here. Again these from this grid there are different power utilization, like coal mine 1, Coal India Limited here, it is taking power from here. There may be lignite, it will be taking power. So, that means there is power generation and power utilization everywhere in the grid. So, this is called grid, and this is high voltage grid. As you can see, this is called high voltage utility grid. That means you can get the power from there. So, then comes the high voltage utility grid. Then comes what? Interface. Interface means this is grid is high voltage. So, this is high voltage, but the utilization is at low voltage. This high voltage is order of 760 kV, as I said earlier, 400 kV or 132 kV or maybe more than that. Then this low voltage is at 11 kV, 6.6, 3.3 like that, 1.1 even 440 volts. So, these are low voltage. So, therefore, there has to be some transformer, and this transformer, what does it do? It steps down. Transformer either it steps up and steps down. So, this transformer is supplied with switch gears. It is connected switch gears. Switch gears means circuit breaker. It is a switch which will close and open, but it is not ordinary switch, because this ordinary switch you see in your home is very low voltage switch which can be operated by hand, but these are very high voltage, also high current. When you switch off a high current, there will be flashover. Therefore, that flashover has to be protected. Therefore, these are called switch gears, and they cannot be operated by hand. They have to be remotely operated by motor mechanism. So, by some kind of automated relays. Then there is control. That means the next is you have to control the motors, because the motor has to high speed, low speed, reverse, etc. So, therefore, there is a control. These controls I have said are called power converters, which are used for control. So, this is the complete electrical power systems of the mine, the heart of drag line again we are going. Okay. Once again, power grid power generating stations, then grid, then utility. This is what is done. So, if you can see here inside a drag line how it happens, you can see this drag line, this AFE stands for active front end. AFE means active front end. I will just explain about this diagram, then we will go to one by one power systems. This is again drag line, I will just explain it little bit, then we will again go back. Let me explain this particular thing. This is called a 3 phase. We will talk about what is known as single phase, we give like this, or 3 phase. So, this symbol is called single phase, this is phi, single phase or 3 phase system. So, for mines, for drag lines it is 3 phase. In your house also there is phase and neutral, there are 3 phases in the transmission, you can see 3 phases. So, this 3 phase system comes here, there is a protection, there are bus bar, there are bus bars here, that means the 3 phase system comes here like this, there are bus bars 1, 2, 3. So, they are connected here, one phase here, one phase here and another phase here, they are connected through circuit breakers. So, these are called bus bars or crow bars, whatever. So, these they are actually having some protection for ground fault. Then it comes analog front end rectifiers, these are called analog active front end, or they are called rectifiers. That means actively it converts AC to DC, these are DC bus. So, all of them convert to AC to DC, alternating current or to direct current. Then after to DC again it is converted to DC to AC. So, this frequency is generally 50 Hz, which is coming from the grid substation, 50 Hz supply. You must have seen in a basic electrical engineering course. This course requires that you should have done basic electrical engineering. So, then here DC to AC, here the frequency is variable frequency, variable frequency here, sorry, not here, here it is DC, variable frequency. It can be variable voltage also, variable voltage and variable frequency, both can be controlled. Who controls this? The frequency and voltage are controlled by and voltage controlled by inverters. Inverters are what? Inverters are essentially power semiconductor switches. It is a combination of power semiconductor switches like this. This is a switch. So, switch, these power semiconductor switches, they are connected in a fashion like this. You know, this is an inverter. You can see this is input is DC, then output here comes in as AC. So, these are switches, power semiconductor switches. We will talk about it in the due course. So, these switches are different switches combinations, they are power. So, what are these switches? These switches are power semiconductor switches, power semiconductor switches is what? Switches power semiconductor. What are they? They are called power transistors, power MOSFETs, metal oxide field effect transistors, then IGBTs, insulated gate bipolar transmission. IGBT full form is insulated gate bipolar transistors. So, these are the inverters. The rectifiers also same, power semiconductor devices. Then there is chopper. Chopper means DC to DC is related, DC to DC. Chopper are for DC to DC, high DC to variable DC. This is fixed DC, chopper makes variable DC. That means voltage can vary. So, these are used for power supplies, and there is over voltage, over current, lots of protection, and these are different motors as you can see. These are different motors. You can transfer from this inverter to that inverter by transfer switch. That means one inverter can drive other motors, there is a transfer switch. So, this is a typical power system inside the drag line. This is a low out. This is called a distribution system, and this is utilization here, the motors are utilized. So, going little further, so this is how the diagram is made generally. These are the called single line diagrams, single line diagrams, single line diagrams. Okay. So, this is 3 phase supply, but it is actually 3 phases, but only one is mentioned here. So, one. Then these are called reactors. Reactors means they are simple inductors. We will talk about that right now. So, they are used to limit the current. Then again active front end here, AC to DC. This symbol is AC to DC, active front end here again. This active front end makes what? AC to DC. This symbol is AC, this symbol is DC. So, this is AC to DC, DC to AC, this is inverter as you see. So, these are the same thing, but these are represented in the form of a formal. This is not a formal diagram, this is a formal power system diagram. This is a power circuit, this is a power circuit, it is called single line diagram. Okay. And these are the motors. So, different kind of motors, they are sometimes fed by 2 inverters, 1 inverter, it is depends upon you, and there are protections. So, this is called a single line diagram. So, with this let us go into little bit of power systems. So, these are different motors you can see like hoist, drag, swing, propel. Hoist motor is up to 1300 to 1750 HP sometimes, and this is medium variable speed, lower speed etc. So, these are some of the motors, but it can increase the speed this HP is, that means about 1 megawatt, but it can be more also sometimes. So, these are some reference. So, let us go into slowly into the electrical engineering. So, you have seen lot of pictures. So, how to start learning about electrical engineering? So, the starting point of electrical engineering is basically the circuits. So, first let us start with little bit of electrical circuits. So, we will start with electrical circuits. So, the major components of or components, you can see circuits and its components. So, what are the electrical circuits and components? So, first one you know everyone is called a resistor or resistance, which is guided by known as Ohm's law, is it not, which is guided by Ohm's law. That means V by I, the voltage by current is resistance, which is fixed in DC. Then comes the second one is known as a capacitor. So, capacitor, you know, Gauss law, etc. So, what is the capacitor tells you? That means the charge is equal to capacitance into voltage. This you know from your physics, and current is equal to dq by dt, that is charge flow, and which is equal to C dV by dt. C is constant. So, this is the law of capacitance, that means I is equal to C into dV by dt. This is capacitor. Okay. Then third comes what is known as inductor. What is inductor? It is a magnetic coil. How does it look like? So, capacitance symbol is like this, right? This is capacitance, and the resistance symbol is. So, what is inductor? Inductor is a magnetic thing, you know, magnetic circuit. We will talk about it. That means, if there is a magnet, that means magnet. That means, suppose I have an iron core like this. Sorry about that. So, one second, let me write resistance, it came back. So, this inductor, then this symbol is, so resistance there, yeah. So, inductor, the symbol is something like this symbol, and if the current is I here and voltage here is V and the L is the inductance, then the law is called Faraday's law. So, I is equal to, or V is equal to, the voltage across the inductor V is equal to L di by dt. So, you have a resistance R, then the inductor L, then the capacitance C, then you must know something like a switch, whose symbol is, so this symbol here is, that means the voltage, when the switch is off, voltage can be anything, current is 0. When the switch is, it will have two positions, off position, the voltage across the switch can be anything, but current will be always equal to 0. If it is on position, it is short circuiting. So, voltage across the switch will be 0 for any value of current, ideally. So, these switches can be made up of, you know what, we will talk how they will be made up of. So, these are the four things you have to understand: R, L, C and S, resistance, inductance, capacitance and switch. So, this makes you the whole of the electrical circuits design, utilization, analysis, everything. Four things, RLC and S. Okay. RLC and S. So, how the resistance is made? Resistance can be made by, you know, resistive material. Capacitance is by two plates and inside dielectrics, and inductor is made by winding a wire over a magnetic core like iron core. That means, you can, inductor can be, inductor how it is made, I will show you inductors next class. So, inductor is made by, you know, iron cores. So, this is a core. So, you can wound wire here. So, this becomes an inductor. So, this is equivalent to, right, this is terminal 1, terminal 2, terminal 1 and terminal 2. And switch can be made by semiconductor switches, by transistors, MOSFETs, etc. And capacitor can be made by putting two parallel plates and putting lot of dielectric here. This is capacitor. So, this is how, these are the four concepts which is going to give you, and the laws are I have already told. For inductor it is L dV by this is the rule, and for capacitor this is the rule, and for resistance this is the rule, and switch this is the rule. These are the 4 concepts you remember. Now, we will get into slowly into the circuits. Okay. So, then the next concept which I will tell you is known as AC and DC. So, there are 2 type of sources. So, operation is sources are what? DC source and AC source. So, this is known as direct current source, right, and this is known as alternating current source. So, that can be, it can be a voltage source or it could be current source. So, this source is very rare. So, we will mostly focus on voltage source. So, let us consider a voltage DC voltage source. So, what is a DC voltage source? You know, there is a battery. So, battery, there are different kinds of battery. The battery which you use, lead acid battery in the cars, lead acid, then you have lead acid battery, then nickel metal hydride in the cameras, then you have lithium batteries which are in your laptop, there are zinc batteries. So, these are batteries, and batteries are very powerful nowadays because batteries are used in electric vehicles and all portable devices. Batteries are all used in all portable devices like cell phone uses battery, your laptop uses battery, most of the portable items like sensing, communicating, they use also battery. And nowadays electric vehicles, there are many in mines, electric vehicles, they use battery. So, these batteries are very popular and it increasing the popularity. Many buses, many cars are battery operated, they are called electric vehicles. So, these are basically battery, and battery technology are catching up like anything, especially the lithium battery is catching up like anything. Okay. So, the symbol is like this and with a source resistance, small source resistance. So, this is battery symbol, DC voltage source. Essentially battery, it can also come from rectified AC, that means AC after rectification, like diodes, you can use diodes, like diodes, you can use diodes, it becomes DC. So, it is called rectification. So, you can also get a DC source from AC by rectification. So, these are all DC sources, all right. Now, go to AC source. So, you can have AC generation, that means if you are rotating a coil in a magnetic field, suppose you have a magnetic field like this, north and south. In this magnetic field, if you rotate one coil which is something like this, if this you rotate this coil, this coil if it is rotated like this, it will undergo north pole, south pole. So, using Faraday's law, you can say that because the flux, change of flux, so voltage EMF or voltage induced is A n d phi by dt. This is Faraday's law. Faraday's law of electromagnetic induction. So, if there is a change in the flux or this coil is cutting the flux, either way there is a change in flux with n number of turns. So, n is the number of turns of the coil. So, this if phi is changing, this voltage will become alternating or AC. So, that is the basic fundamental of the generation. When the flux is changing, because of the rotation or anything. So, voltage induced here across, if you see in a CRO in a digital storage scope, this voltage this will oscillate. So, this is AC source, and the symbol of AC source is something like this. So, I will recapitulate. So, what did you learn? You learned 4 things here: resistance, capacitance, inductance and switch. Then you learned DC source and AC source. You also have voltage source and current source. Voltage source is what? That means, irrespective of the current you draw from here, the voltage here remains fixed. This is voltage source. That means, if you connect a load here, some resistance, if you change and keep on changing the resistance, this voltage will be almost constant. This voltage across this. Same thing here. If you connect a load, even if you change the load, the voltage across this will remain constant. So, this is called voltage source, right. So, this is what you learnt. So, now let us go to the next. So, then you have to do AC circuits and DC circuits. So, what is a DC circuit? Then DC source and resistance, because inductor and capacitor, they in the DC circuit they have no utility. So, DC circuit, for example, I can have one battery, I can have a series of resistances, I can have resistances like this, I can have a network of resistances. This is your voltage source E, these are resistances R1, R2, R3, R4, R5, R6, you can have resistances here also, R7. So, these are resistances. So, you have to solve for current in different branches. These are DC circuit. So, in DC circuit, this is called steady state, that means the current will not change. You can have DC circuits which are having switches also, like here. This is R, this is L, this is voltage or V or E, and there is a switch. So, you may be asked to find out the current I, IT after the switch is closed. So, you can write the equation R into I plus L di by dt, that is voltage across this and voltage across this is equal to supply voltage. This is called Kirchhoff's voltage law or KVL. Kirchhoff's, this you did in your undergraduate, Kirchhoff's voltage law. Similarly, in AC circuit, you have an AC source, then there is resistance, there is inductance and there is capacitance. This is RLC series circuit, this is voltage source Vt, this is RLC, because it is always changing. So, you can write like this current is I. So, R into I plus this current is I here. So, L di by dt plus C into Q, Q by C, that means 1 by C into Q is equal to the applied voltage Vt. This is Kirchhoff's voltage law. So, you can write R I L di by dt plus 1 by C, Q you can write I dt dash integrator and 0 to t, that is Q is equal to Vt, supply voltage. So, this is again Kirchhoff's voltage law, KVL. What is KVL? That means KVL tells you that voltage around the voltage drop should be equal to voltage rise, or voltage rise minus voltage drop should be equal to 0. If you consider rise to be positive, drop to be negative, total voltage in positive around the loop, this is one loop, will be 0. Then similarly, there is a Kirchhoff's current law, that means at a node current, total current coming in is equal to total current going out. So, that is called Kirchhoff's current law. That means, in a node, for example, So, this is the node. So, if this current is I1, I2, I3, I4 and I5, I6, then I1 plus I2 plus I3 plus I4 should be equal to I5 plus I6, or you can just subtract 0. So, sum of the current at a node, if you take the signs properly, it becomes 0. So, I have covered. So, in a nutshell, I told you about few things. One is the different electrical elements like resistor, capacitor, inductor and a switch, and the governing laws like Ohm's law. Here it is ICV, that is electrostatic law, which is I is equal to C dV by dt current. Here it is Faraday's law, voltage is equal to L di by dt, and here switch, which can have on and off. So, switch is not linear, and these are all linear relationships. We will talk about it. Then we have two sources, one is called DC source and AC source. DC source is direct current source and AC source is alternating current source, and you have a voltage source and a current source. Mostly when the terminal voltage remains constant irrespective of the load, it is a voltage source. When the current remains constant instead of irrespective of any load, if the current remains constant, is a current source, and mostly we will deal with voltage source. And we have DC voltage source, it can be AC voltage source. DC voltage source are mostly batteries, which can be lead acid batteries, nickel metal hydride batteries, lithium batteries, lithium ion, they are called lithium ion batteries. Then they are used in portable devices such as cell phone, laptop, battery, electric vehicles, sensor nodes. For example, if there is a water pipeline, lot of pipeline, you want to put smart water meters, these water meters are essentially driven by sensors. These sensors and computation, this will be done by batteries, because there will not be computing everywhere. So, these are sensor nodes. So, they have their portable devices which are supported by. In mines, there are many places where you cannot access, the power supply is not there. So, there you have to use portable devices, because power supply is not possible, and the mine is constantly undergoing excavation. When the mine is constantly changing, the geography is changing, the surface is changing, you cannot have electricity everywhere. So, therefore, the sensor nodes has to be, there will be batteries. So, these are DC sources which are very useful nowadays, and nowadays most useful because of electric vehicles, and they are driven by lithium batteries, and these electric vehicles, they are everywhere, the cars, bus, lots of things are driven by batteries. So, these are because of battery sources. Then you have AC source essentially the generators. The generators operate in the principle of Faraday's law. Whenever there is a rotation in a magnetic field, the voltage is induced, and by this is the law, E is equal to N d phi by dt. So, as you have seen, the turbine, the steam turbine drives a alternator, which is essentially lot of conductors rotating in a magnetic field, and that generates AC. So, now let us see what is the difference between AC and DC. So, these are different circuits. This is called DC circuit, where resistance and sources are there. There can be transient, that means when you put a switch, it will be a transient. So, you can have this kind of equation, and similarly AC circuits will have transient and steady state, and they are governed by these equations. So, now we will move to primarily AC circuits, and we will consider what is single phase and three phase. So, now we will consider the phase concept. So, the generation, AC generation is generally sinusoidal, because sinusoidal voltages are easy to transform and there are less losses, and all the systems are designed based on this concept. Sinusoidal means you can write that voltage generated is a sinusoidal quantity, some magnitude V max into cos omega t. This is how the voltage generated, and this can be done by a proper winding arrangement. And if there is a magnet like this, north and south, and there is a coil which is rotating, this coil, this on a rotor, this is a rotor, this is rotating, this coil is rotating around this, and the coil the coils are taken out here by slip rings, etc. So, the voltage generated will be sinusoidal. This assumption we will do. So, when the voltage generated is sinusoidal, you will find the in a RLC circuit the current will also be sinusoidal. Let us see. So, if I put a RLC circuit, this voltage is sinusoid, I am put plus minus. So, this is resistance, this is inductance, and this is capacitance. This is R, L and C, and this is the voltage V t, this is V m cos omega t. So, if you find out the current I, how to find the current I t? So, you will find R I plus L d I by dt plus 1 by C into I dt is equal to V t, that is V m cos omega t. This is a linear differential equation. This is called a linear differential equation. You can also write this in the form of voltage across the capacitance. If the capacitance voltage is V c t, so you can write this one 1 by C 0 to t. So, that means the current in the through this current will be what? I t. I t will be C dV c by dt. Is it not? So, you can write this in the form of voltage law also. That means, this voltage will be L di by dt, voltage across the inductors, this is voltage across the resistance V r, and this is V c. So, V r is the voltage drop plus V L is the voltage drop in the inductor, V c is the voltage drop in the capacitor is equal to the applied voltage V t. So, V r is I into R, V L is L di by dt, and V c is V c is equal to V t. So, what you can do is here in place of I you write this, you plug in I V c t here. So, what will happen? R C dV c by dt, I just plug in I here, and then L I is equal to this. So, double I L d by dt of I is this. So, L d I by dt of C dV c by dt, then this is plus V c is equal to V t. So, if you write it properly you will find this is L c d square V c by dt square, this term, plus R c dV c by dt plus V c is equal to V t. And what is V t? V m cos omega t. If you solve this equation V c, this will turn out to be also sinusoidal or cosinusoidal. It will be V c max, some V c max cos omega t minus some phi c. This will be the solution. We can take this solution and plug in here V c d square, and you can find out V c, and you can from this you can find out the, once you know V c you can find out I t. So, if you plug in here you will find I t turns out to be, so I t solution will become, this I t solution will become some I max cos omega t minus phi. This is the nature of the solution of the linear differential equation. These are called linear differential equations. That means, if the supply is sinusoidal or cosinusoidal, the current will be also sinusoidal. So, that is the whole thing. That means, if this, so if you solve this, I am not solving because there is no need, you can just take the solution. So, if I solve this whole thing, you know what will happen to the I m. So, I m will turn out to be, in this particular circuit I m will turn out to be Vc max r square plus omega L minus omega C whole square to the power half cos omega t minus phi, where phi is equal to tan inverse omega L minus 1 omega C by r. This solution we will get from this circuit. This is R L C. This is your IT. So, what is the supply voltage V t? V t was this. So, you see this is cosine, this is also cosine. So, this frequency is omega, this frequency is omega. So, frequency does not change everything, so it is a linear circuit. So, this has a different method of solution, this is known as phasor solution. We will discuss next class. So, I will just before that I will just recapitulate everything I told about, you know what, electrical circuit components, resistor, capacitor and inductor, and switch. Resistor is Ohm's law, capacitor is I CV by dt, it is coming from the Gauss law, etc. Then inductor is V L d by dt from Faraday's law. Then there is a switch, and there are two kind of sources, AC source and DC source, which could be voltage source and current source. DC source are battery, which are very popular nowadays, electric vehicles are one of the example, and AC source are natural, which is generated, and the principle governing is Faraday's law. The voltage generated is N d phi by dt, N is the number of turns. Then we have DC circuits and AC circuits, and they can be solved by equations KVL and KCL. KVL transfer Kirchhoff's voltage law, where the voltage around the loop drop is equal to rise. Similarly, Kirchhoff's current law, current in into the node is current coming out of the node, and there is a phase concept in AC circuits, and you can go for solution. V t is equal to V m cos omega t, and V t you can see by this, if this voltage supply is sinusoidal, the current is also sinusoidal. Thank you very much for your patience. So, we will move to the next class. Thank you.